Gas scrubbing refers to the process of removing pollutants from a gas stream. There are many types of scrubber, and most of these will use our spray nozzles in one part or another. Now, this short video lists the various types of scrubber in which our spray nozzles are deployed, and in future videos we'll go into some more technical detail about the types of spray nozzle for specific scrubber designs, but this video is just a quick overview. So first of all, let's look at wet scrubbers. Wet scrubbers allow a gas to come into contact with a large volume of scrubbing liquid, which will remove contaminants. Now, these contaminants can be solids, liquids, or gases. This is one of the main advantages of wet scrubbers. They can get rid of all three different types of contaminant. And the basic idea is to get as much of the gas into contact with as much of the scrubbing liquid as possible, and the resulting gas which passes through the liquid will then be cleaned, and it will be saturated with liquid, and in many cases will be cooled significantly, which will result in that saturated water condensing out of the gas, hence the term wet scrubber. In a basic wet scrubber design, the gas is passed through a sprayed liquid as shown in this diagram. In some scrubber designs, the gas flow is deliberately forced into a narrow throat. This rapidly speeds up the gas flow, and this speeding up of the gas flow helps to better atomize the sprayed liquid. This is known as a Venturi wet scrubber. Another design of wet scrubber in which our nozzles are deployed is a packed bed scrubber, and this uses a different principle to increase the surface area and contact between the scrubbing liquid and the gas. In this design of scrubber, the liquid is sprayed onto a packed bed media and it trickles through this, and at the same time the gas passes up through this media bed, and the media is made of geometrically complex shapes which serves to increase the surface area of the liquid as it trickles through, and thus increase the contact with the gas. So now moving on to dry scrubbers. Now, a true dry scrubber will use powdered reagents to react with the contaminants and remove contaminants from the gas, and so do not require spray nozzles to spray the reagent into the gas flow. However, in most designs it is necessary and highly desirable to pre-cool the gas before it is reacted with the dry reagents, and this is normally achieved by spraying water into the gas and using the evaporation of the water to rapidly cool the gas. In these dry scrubber designs, only enough water is put into the gas so that it doesn't become oversaturation point when cooled, so it doesn't condensate out, so that it remains dry. The purpose of pre-cooling the gas, of quenching the gas for a dry scrubber, is twofold. First, it contracts the gas down so it occupies a smaller volume and so slows down the gas flow, so you've got more time for the reaction to actually occur to remove the contaminants. And secondly, these gases can be very, very hot sometimes, and so cooling them down serves to protect the scrubbing part of the scrubber from the very, very hot gases. So whilst spray nozzles aren't used directly in true dry scrubbers to actually scrub the gas, they are a very, very important component in the pre-quench part of these scrubbers. So now moving on finally to semi-dry scrubbers. In a semi-dry scrubber, a wet slurry is sprayed into the gas flow, and this then reacts with the contaminants in the gas to form a solid. The gas actually remains dry despite the fact that a wet slurry is sprayed into it. Now, the most common type of scrubber is used what we call flue gas desulfurization. So this is removing sulfur dioxide gas from a gas flow by spraying a lime slurry, lime liquid, into the gas, and this reacts with the sulfur dioxide to form a solid calcium sulfite dihydride, also known as gypsum, and this solid then falls out of the gas and is removed as a contaminant. So it's known as semi-dry because you're spraying a liquid into it, but the actual contaminant that's being knocked out gets turned into a solid. So our spray nozzles are key components in all of these types of gas scrubber. It's core business for us. We advise engineering companies around the world on correct nozzle selection for all of the different types of gas scrubber that we've talked about. We can advise on nozzle selection for all of these different designs, and in future videos we'll look at some of the important spray characteristics like droplet size and spray angle when it comes to nozzle selection in gas scrubber design.